Hey guys, hope you're having a good day. Check out these little visitors we had over Christmas break. These are Miss Piggy and I can't remember the other one's name. Anyway, they came from my daughter's science class at Henley, and they are the cutest little things. They look sort of funny. They have funny little toenails, but they make the best noises. In the middle of the night, you'll hear them going, weep, weep, weep. Or when they hear the food coming, they start doing the same thing. Absolutely adorable. All right, let's get on with today's topic. We're going to learn how to simplify radicals. All right, now you guys know how to do this because these are all perfect squares under the radical. All right, so square root of 4 means what number times itself equals 4. So of course that would be 2. All right, now you take a second and fill in the rest of those, and then I'll show you the answer. All right, so I hope you got those right. And now we'll move on to some harder problems. Remember, you've got to have them memorized up to the last perfect square, 400. Square root of 400 is 20. All right, now we're going to simplify some other radicals. All right, how do you know if a radical is simplified? All right, what you have to do is look at the number under the radical. You cannot have any factor of that number that is a perfect square. All right, write that down. To be simplified, the number under the radical cannot have any factors that are perfect squares. All right, so let's look at the square root of 8. So what you want to do is find the largest perfect square that is a factor of 8, and then what you multiply that number by to get 8. All right, now this one's pretty easy. You're going to start with 8 equals 4 times 2. All right, now the square root of 4 is 2. So I'm going to mark through that and bring it to the outside of the radical. Square root of 2 just gets written over beside it. So square root of 8 is simplified as 2 times the square root of 2. All right, square root of 20. All right, I need the biggest perfect square that goes into 20. All right, so that would be 4 times 5. All right, the square root of 4 is 2, so that comes to the outside. Square root of 5 can't be simplified, so that stays beside it. All right, 32. Now, a little trick you want to know is to start with dividing the number by 2, because there's many factors that multiply together to give you 32. But if you divide by 2, then you're going to hopefully find the biggest perfect square right away. All right, so if I say 32 divided by 2, and you can use your calculator for that, you get 16. And I know 16 is a perfect square. So 16 times 2 is 32. All right, and then the square root of 16 is a perfect square, so that's 4. And then I'm left with times the square root of 2. All right, 75. What two numbers multiply to give me 75? Well, if I divide by 2, I get something like 37.5. All right, that's not a perfect square, but I'm going to think about the numbers that are perfect squares that are less than 37. All right, so the first one would be 36. Okay, 36 doesn't go into 75. But the next perfect square under that is 25. And 25 does go into 75. And it goes in 3 times. All right, so 25 is your perfect square. That comes to the outside, and you're left with 3. All right, 140. All right, let's see. If I divide by 2, I get 70. That's not a perfect square. So I'm just going to go down my list for the perfect squares under 70. So next one's 49. That doesn't work. Next one, 36. That doesn't work. 25 doesn't work. Going down the list again, 16 does not work. What's going to work? Does 9 go into 140? No. All right, and then we're down to 4. All right, 4 does go into it. 4 times 35 is 140. Take the square root of 4 to get 2. times the square root of 35. And you're done. All right, this next one has a lot bigger number here, and it has a variable. All right, now you're going to start with dividing this number by 2 and see if you get a perfect square. All right, so 722 divided by 2 is 361. All right, that is a perfect square. Now, you have to look at x to the third power. All right, you're trying to take the square root of a number. So x to the third means x times x times x. So x squared times x would be the same thing. All right, now you're ready to simplify. Square root of 361 is 19. The square root of x squared is x, so that comes to the outside. And what's left under the radical, you have 2x. All right, if you hear that noise, that's Hoover beating her tail on the couch because she really wants some pets. But hey, we've got to learn some math here, so let's get going. All right, big number here again, 300. All right, anything that ends in a double zero is going to be divisible by 100. So there's my perfect square. All right, so this time you also have a number out in front, so you're going to copy that down, and then we're going to break it down here. All right, 300 is going to be 3 times 100. 100 is our perfect square. All right, x to the fourth. How could I rewrite that so I have numbers that I can take the square root of? All right, let's try x squared times x squared. All right, then y to the fifth. You could have y squared times y squared times y. All right, that would give me 5 y's for y to the fifth. All right, once you have it all broken down so everything under there is a perfect square, then you're going to simplify. So let's bring down the 4. All right, 3 stays under. Square root of 100 is 10. So you're going to bring that to the outside and multiply it by the 4. Square root of x squared is x. Bring that out. Square root of x squared is x. Bring it out. Y squared, y. Y squared is y. All right, now you got to figure out what's left under there. You got a 3 and a y. All right, now all the stuff out in front gets multiplied together. So you got 4 times 10 for 40. X times x is x squared. Y times y is y squared times the square root of 3y. All right, now we're moving on. All right, we're going to add and subtract radicals. All right, so look right here. It says to combine radicals, you have to combine the coefficients of like radicals. So the only way you can add them is if the number under the radical is the same number. All right, so let's start with something easy. Let's say you have 3 square root of 2 plus 4 square root of 2. All right, if you add those, since they have the same number under the radical, you can add the numbers out in front, so you get 7 square root of 2. All right, if you see something like 4 square root of 3 plus 2 square root of 2, you can't combine them. They can't go together because the number under the radical is different. All right, now, Hoover has an itch and she's scratching. Listen to that jingling. All right, here we go. Add after you simplify. All right, so if I look at these, I say, oh, can't do that problem because the numbers under the radical aren't the same. You don't get off the hook that easy. We got to simplify them. All right, so I'm going to first look at 3 times square root of 27. All right, so we're going to start. We're going to break it down. All right, so what perfect square goes into 27? That sounds like, how about 9 times 3? All right, then we're going to look at 48. All right, now, if you try 8 times 6, neither of those numbers are perfect squares. So remember what I said about dividing by 2. All right, so 48 divided by 2 is 24. All right, that's not a perfect square. So look in your list at the next perfect square smaller than 24. All right, so that number is 16. All right, so we're going to have 16 times what equals 48? Help me out here. What is it?
3.
3. Excellent, Bob. Thanks. All right, now, what are we going to do next? All right, we're going to bring down that 3. We can break it down here underneath. Square root of 9 is 3, so that comes out. Square root of 3 stays under. All right, plus 5. All right, what's square root of 16? Excellent. We got 4. Cross that out, bring it to the outside, and you've got 3 underneath. All right, simplify out in front. 3 times 3 is 9 times square root of 3 plus 5 times 4, 20, square root of 3. All right, same radicals. Add the numbers out in front. 29 square root of 3. Oh my goodness, aren't you smart? All right, let's try one more here with subtraction. All right, so we got to break down square root of 50. All right, so divide by 2, I get 25. Lucky me, it's a perfect square. All right, so I got 25 times 2 minus 3. All right, 32 divided by 2, 16. Lucky me, another perfect square. All right, so then simplify, break it down. Square root of 25 is 5. Bring it to the outside. Times 2, break down square root of 2. Minus 3, square root of 16 is 4. And you're left with a 2 under the radical. All right, 5 times 2, 10, square root of 2. Minus 12, square root of 2. Coefficients are going to give you negative 2, square root of 2.